Okay, now that we had, I should say, a basic understanding what is a credible or uncertainty interval in the Bayesian framework, now we can just move on to just implement that inside, I should say, the R, and see that how is that just going to work in R. I should say the women data sets that we just started that from previous tutorials. Okay, in order to find the confidence interval, and I should say the credible intervals, confidence within the frequentist approach, but credible intervals within the Bayesian framework. For the Bayesian framework, still we are in need of the R package that we installed that before. I assume that you have that package already installed on your system. Then as a result, I'm just gonna call one of the functions inside that package, which is called posterior interval. Then you see that we have, then you just type the posterior. If you are doing this coding in the R environment, R Studio, you see that there is a drop-down menu. It opens many different functions of, I should say, of the posterior, which is inside the R package, and hopefully we should be able to just cover the majority of them before we finish these tutorials then. Okay, I'm just going to go to check the posterior interval, and I'm just going to choose that. And I'm just going to go to find all the arguments which is essential in order to place them inside the parentheses. In order to do that, I'm just going to go with the file to press F1 and find help. And I'm just going to go ahead, the posterior uncertainty interval, click on this one, and I'm just going to see the result of my search. And I can see that, for example, I can just go ahead with the usage, and I find the arguments that I need to just put that inside these parentheses. Okay. The first one, I need an object. The object is going to be my Bayesian model, which I created. It was model A. Okay. It's going to be my first argument. The second argument, you see that's going to be the probe. What is a probe? Which is by default is a probability that we said that. This, as you remember from the previous tutorial, we said that with the concepts of the credible interval, we have a particular probability that the unseen parameter falls within the range of the parameters. And that's going to define the probability by default. The probability is defined as a 90%, which makes the computation much faster and more stable. But you can change that on, I showed that in the next, I should say, example, I showed that how you can just have a different results if you change the probability from, for example, 90 to 95, or let's say, for example, even 50. Okay. The next argument is going to be the central, which is the only argument that we have to just put, and that's going to be a kind of a default. We have not many other options for that thing. If you do not also put that there, it's going to just be wrong because that's a default. And also, we have this argument here, which is going to be the essential one, the part, especially for the case then when we have multivariable regression analysis within the Bayesian framework, then we have to just go ahead and to just determine the covariates that we are looking for, the credible intervals for the parameter which is assigned to that covariance. For our case here, we are just going to go ahead with the weight of these women. And so far, it seems that we should be totally fine with all the required arguments that we had to just put inside that posterior intervals. I'm just going to execute that. And you will see that when I execute that command, you have the result that, for example, between the probability between 5% and 95%, which it's going to be essentially our 90% probability, the slope that we had to make it, that we made an inference about that, it's going to fall within this interval between 0.2735 and also 0.315. You see that that's going to be the thing that we have. We say that, okay, we have a probability in terms of the interpretation of that. You can say that now we have a 90% probability or you can say that you can be 90% sure that the value, the true value of the parameter, which is going to be the slope of the weight in our model, is going to fall within this range. Either it can be, for example, between 0.27, goes all the way to 0.30. And if you remember from the interpretation that we had, I should say, on our framework on a couple of tutorials before, we had the value assigned in our Bayesian framework. I'm just going to go back to the slides that we have. I'm just going to show that to you, the value that we we made an inference about for the weights. It's got within the Bayesian framework, the height, it was, I should say, 0.3. And if you just go here, you see that 0.3 is still in that framework. And that's the thing that we just wanted to talk about that. Okay. Now, also, you can just go ahead and change the 95% to the 90% to 95%. And when you run it, you see that there is now still 95%. You see that the range that you have, it's going to be, I should say, smaller. You have to, you see the lower bounds and the upper bounds. When you're talking about the 95% probability, it is going to be within these lower and upper bounds. Still, you see that the true value, we say that 95%, there's a probability, which is 95%, that the true value of the slope of our linear model is going to fall within this range. It can be from 0.27 goes all the way to 0.3. Also, you can come here to change even the value to 50%. You see, what is that going to be? And you see that when you are the probability, when you just assign lower probability, you get a different interval. You see that, okay, you say that I am 50, there is a 50% probability that the true value of the slope is going to fall within this range, which is going to be even, it doesn't include even 0.3, which we extracted that from, I should say, our inference on the sampling which we had on the Monte Carlo the algorithm that we had before. And you see that you can change the probability to different values, and you get different results, you get different intervals. And normally 95%, if you just say that the probability is going to be 95%, you see that you can change the probe to 95, 0.95, then you see that you can get an interval which you say that the unseen parameter, which is going to be the slope of the weight, is going to fall within this range. But we know that also from the previous modeling that we had, we saw that from the sampling algorithm that we had, we just extracted the slope as up to be 0.3, and now we see that even with the probability of 95%, we know that, I should say, that slope is going to fall within that interval, which is 0.27 all the way to 0.3. And essentially that's a very close thing that we can see that it comes with our, the slope, which we extracted that from our previous discussion now. Okay, that's about how to extract the posterior interval or the credible or uncertainty interval within our regression Bayesian analysis there. On the next tutorial, we're just going to extract a very similar result within non-Bayesian framework and compare the credible intervals with the confidence interval within non-Bayesian framework.